observatory in the country. And just by coincidence, the University of Antananarivo has been built next to that observatory some years later. So yeah, that's the how do you call him? He is Colin Favre Colin, who came in 1889 to establish the observatory. And most of the activity back then was to help also with respect to meteorology. And fast forward, what happened to the, okay. In between, there have been activities of astronomy, but it slowly died down until 2006, when Madagascar joined South Africa as one of its country partners to host the Square Kilometer Array project. And one plan, as part of that plan, is to convert one old radio telecon as a radio telescope. And through this partnership, Madagascar was able to send students to conduct master's and PhD program at some South African-based university. And that's the picture you see there during one of the SK conference. And through the partnership, 10 students could get their PhD in astronomy and astrophysics since 2008. But then we realized that it was not a sustainable way to only send students in South Africa, plus funding for international students became limited. So that's why in 2014, with the help and intervention of Prof. Minsonra Kutumalala, we've established a curriculum for master's degree at the University of Antananarivo in Madagascar. And the plot that the diagram that you see on the left is the number of students per intake since the establishment until now. There is a gap 2021 because of some strikes and the COVID pandemic that was affecting the academic year at the university. What you see is 2014, 2015, it was only all male, 7, 8, and in 2016, there were 2 female students. 2017, only 1 male and 4 students, and so on. So since 2014, 49 students enrolled in the master's program and 15 students were graduated. Some students are still conducting the research, but some also discontinued. That's one of the challenges in conducting research such as astronomy in developing countries. The research area that you are covering span from extragalactic optical and radio astronomy, observational and theoretical cosmology, but you also offer project for instrumentation. Who are we? Those are the students who were graduating from the university based in South Africa, supervising students back in Madagascar. Myself, for instance, over those past, since 2016 that I've taken students, I've supervised 5 students and currently supervising students. 2 of them are not doing their PhD in Europe, and 1 is still conducting your research, and Tumbu just finished recently. And for those of you who will be at some point attending Science Talk, feel free to attend the talk of Tumbu and Miura. And yes, there are also students who discontinued. She was a female student. So we've realized that just waiting for supervisor to give support was not enough. There was also a need to put a system to support those students. So at the beginning, the whole idea of creating Malagasy Astronomy and Space Science was for us to give support for students so that they can, to help them achieve and complete their degree. But you also realize that there is a need to involve the other PhD holder Malagasy astronomer. So that's when we've split the category of membership into three types: the professional ones, anyone that has a PhD in astronomy, and the main goal is to support the student. And then the student, their main goal is to support the amateur members. And for the amateurs, they are the one who are participating to most of the activities, but also help the organization to promote public outreach event. So yeah, Malagasy Astronomy and Space Science, it's really a network of both professional and amateur astronomers in Madagascar with a vision, a mission to promote science and astronomy in Madagascar. There were a lot of activities that we've been conducting since our establishment. It can be split into three different categories: the ones that are really research-based, such as the annual workshop for master's students, or the monthly skills transfer for MSc students. And then we also have a regular event such as le Rendezvous des Astrophiles. It's a national astro quiz to engage more with the public, apart from running primary and high school visits. And during the pandemic, we've also really leveraged social media to run our outreach activities. Some of the events that you are all also doing is the IAU and RED celebration and the Astronomy Week in 2021. If you talk about the advancement of astronomy in Madagascar, then I think one thing that really helped was the first ever International Astronomy Conference back in 2018 with the sponsorship by the IDA, and the focus of the meeting was about big data conference, and with the participation of the African partner countries of SARO. And because of all this momentum, and Malagasy Astronomy and Space Science now grouping together the professional members, Madagascar could join the IAU as an observing member in 2018 during the General Assembly in Vienna. So here I'm just spending a moment to talk about the annual workshop. It was first launched in 2017, and since then we've done our 4th edition back in September. That's supposed to be 2021, and it's basically a 3-day intensive workshop where you not only share research skills to the student, but you also share them soft skills and any basic skills about outreach, because sometimes you realize that those students who are doing master's students haven't even done any stargazing. So we also incorporate outreach activities during those annual workshops. And one way that you are moving forward is to launch our network of Malagasy amateur astronomers under the guidance of the IAU OEO and OC Madagascar. So at the moment, there are 2 strong associations of astronomy association that promote the science in Madagascar. That's Malagasy Astronomy and Space Science and Aikidan Astronomy. But we've realized that most of our events are focused in the capital, and would like to decentralize that by establishing over astronomy club all around the country. So one way to do that is first to run a workshop that will help identify potential astronomy club leader. So to summarize my talk, yes, there is definitely an increased interest in astronomy in the right island, and we shouldn't forget that non-profit organization and civil society, they are key stakeholders in advancing the field. You shouldn't wait for what is happening at the university or the government, and you should really involve youth in project implementation because they still have the energy and the time and the passion. If you want to find out more about the current status, then there is a proceeding that was published during the IAU Symposium 349, and you can also follow us in our social media Facebook account. Thank you.
Thanks so much, Zara, and thanks also for keeping time. I think we can all learn from how a well-defined and structured astronomy program, aimed at everybody in society can be done from Madagascar. What I will do is that I will just go on to the next speaker. If we have time, we'll have questions at the very end. If not, please join Slack, and you can ask questions in Slack for today's speakers, and they'll answer it tomorrow. So let me then go on to the next talk. Thanks again, Zara. Next talk is by Edward Jurua from Barara University of Science and Technology in Uganda. His topic is building human capacity from scratch, and he's going to tell us how they increase the number of students by order of magnitude recently by training people locally. So yeah, Edward Jurua, please go ahead.
They didn't give you. I shared it on Google Drive, I think.
Is Edward Jurua there in person?
Yes.
Yeah, just 1 minute, Niluj. We're waiting for the presentation.
Okay.
How are you, by the way, Niluj? Fine.
Oh, good, good. Thank you. So if it's going to take a minute, do you want to shall we take one question for Zara quickly? Is there any quick question for Zara right now?
You can explain the time. This question for Zara. Any question?
Till Jurua sets up his talk.
1 or 2 minutes delay for the presentation. They're just looking at it in the hard drive.
Okay. Yeah, so if not, I do encourage all of you to go to Slack. Last year's Slack was very active, this time not so much. You can ask questions to all the speakers there, and speakers can take their own time to answer them throughout this week. So please do post your questions on Slack. Yeah, there's a question from Tunisia. Is the master's program open for international students? Zara, you want to take that quickly?
Open for what?
Is the master's program open for international students as well?
Of course, if you register at the University of Fontainebleau, then yes, we are open to any application. But so far, all those 49 enrollment are anyone based from Madagascar.
Okay. Thanks, Sarah. Yeah, there's a question from Nejmadin from Tunisia. Yeah.
They're all set now, News.
Okay, perfect. Let's move ahead then. Thanks, Sarah, again. Now we have Edward Jurua again from Uganda, from Barara University of Science and Technology. I'm going to steal the last 2 minutes away from you for the questions, and I'll remind you after 12 minutes or 10 minutes. Please start.
Thank you very much. Apologies for that delay. I'm going to talk about how you can develop human capacity from scratch. And in that case, I'm going to use our testimony to do that.
Oh no. Because there is no internet.
Oh no, there is internet.
There is.
This is the connection. Maybe the connection from the surface. Yeah. Then is the load sharing today? No. Okay. You can share with one.
Is there no power when I say
Is power. So it's only that laptop. It's not connected.
Yeah.
So,
maybe I'm just gonna this.
News, we have a... Can you hear me from?
Yeah, Jamal, sorry. What did you say?
No, I think you can use it. You can't use your mic when you speak. Yeah, no, but you are online. It's working. Okay, so fine.
Okay, are we ready to go?
Sorry, man.
Just 1 more minute or two because we have a small technical problem. So,
Okay.
okay, it's fine now.
Linda Struber, are you going to present it on Zoom?
1 minute, 1 more minute, please. We still have a slight problem to solve. Okay.
Okay, sorry for what happened. So I was saying that I'm going to talk about how you can develop human resource capacity from scratch, and I'll use our testimony to do that. For those who have been listening to our talks, we introduced the astronomy in 2002, and that was mainly in the form of outreach to secondary schools, where we go and motivate students to do sciences, because by then, the number of students opting for sciences has been low. And with that introduction, we discovered that the number of students who got interested in sciences increased. And as a result, we also looked at the increased number of students who finished their studies in physics in the third year. And of course, that made us to realize the power of astronomy, which we can use to motivate and attract students to do sciences, which of course we know that science is very vital for technological development. And of course, that will mean that a subject like astronomy needs to be developed further. And the key in the development is to build human resource capacity, because without human resource capacity, you may not move far. And of course, that's not only in academics, but in every other area. And we discovered that the easiest way for us to develop human capacity is through training of postgraduate students, which you can do at master's level or at PhD level, in addition to also training the existing staff in astrophysics. Now, for you to introduce astrophysics, of course, this cuts across. The first thing is the curriculum. I think this is in line with what Prosper talked about earlier. So our starting point was to develop a postgraduate curriculum in astrophysics. Now, the first thing is to do a baseline survey to see what you need to include in the curriculum. And for us to do that, we had a number of meetings with experts or professionals from different institutions, from different universities in Africa and outside Africa. Examples of the institutions that we had discussions with is the University of Cape Town, then the South African Astronomical Observatory, which has been key in training human resource in Africa. Then in Europe, we had discussions with the experts from Lund University and also from Stockholm University. Now, these discussions led to the development of a draft curriculum, which was then discussed. And of course, after discussing, it has to go through the approval process. And for our setting, it's first submitted to the Senate, and after Senate is happy with it, it goes to the body which accredits the curriculum. And in our case, it is the National Council for Higher Education, which does the accreditation of the curriculum. And once it passes through, then that's only when the course can be, or the program can be started. So now, in addition to the curriculum, of course, the other things that you may need to be able to train students, like you need books. And of course, that meant that there was a need also to look at establishment of a library where students can get access to books specifically for astronomy or astrophysics. And of course, journals also where they can subscribe to journals and so on. And of course, you know that in astronomy, you cannot do astronomy without computers. And we also saw the need to establish a computer laboratory. And of course, this is useful, like I mentioned earlier, particularly for students who don't have computers. Now, so what we had at the postgraduate program, we looked at 2 courses. The first one is the Master of Science program, which is 2 years. And of course, there's normally a grace period of 2 years for those who may delay due to one or other reasons. Now, just like what Prosper mentioned, we also have 2 components of the master's program, which is coursework, which is taught for 1 year, and then research is also for another 1 year. Now, of course, the courses that we developed, these are in addition to other physics courses. So we have stellar structure and evolution, we have extragalactic astronomy, high energy astrophysics, computational physics, planetary science and exoplanets, and then we have the observational techniques. Now, we also have a master's program, which is by now it is pure by research, 3 years, and of course, there's also a grace period of 2 years to make it 5 years. And we have developed another curriculum based on the advice from the National Council for Education, where they need us to introduce some cross-cutting courses for PhD students. Of course, these are not in the specialized areas. Now, what are the key research areas that we have? We have astroseismology, we have extragalactic astronomy, high energy astrophysics, and also we have planet formation. So these are the key research areas that we have. Now, how did you start the teaching? Because by the time we developed this, human resource was, I think there was only 1 person on ground. And of course, we have a number of courses which needed to be taught. Now, where did you get the human capacity to start? Now, key is collaboration. So what we did was like, we copied what happened in the NAS program, for those of you who know about NAS, to organize compact lectures for students where we invite visiting lecturers. Now, this is one of this is a class where we had a visiting lecturer. Of course, for those of you who know, this is Professor Donald Quads, who came to give a compact lecture. Normally, they come for a period of a minimum of 2 to 3 weeks to give compact lectures for students. Now, this is in addition to what we provide locally. Now, in addition to the lectures, we also organize workshops for students. Now, these workshops are for research techniques where they can learn about data analysis. Now, in addition to that, we also send students for research visits to some of the institutions that we collaborate with. But of course, this only benefits a student. But when we have trainings locally, it benefits a bigger number of students. And that's what we normally opt for. Now, students, we can send them for a minimum of 2 months to go and spend time, of course, with some of our collaborators. And of course, when they come back, they also have engagements with their colleagues on what they have learned. Okay, now, gender balance is something that we also take very seriously because we need to also motivate female students. Of course, you know that female students, they have challenges, which in most cases prevents them from proceeding with their studies, and particularly even in sciences. So we also have meetings with our undergraduate students where we talk to them to motivate and encourage them to continue with their studies at postgraduate level. And here we use our female students who are already graduate students, because it is easier for the girls to relate with their colleagues at a certain level. And we found that this has really produced results, which you will see shortly. Now, who are the people I've been collaborating with? We have a number of institutions in Africa and in Europe. Of course, we have the South African Astronomical Observatory, we have observatory in Germany, we have the Royal Observatory in Belgium. We have the Max Planck Institute also in Germany. We also have in France, in India. In Africa, we have the Ethiopian Space Science and the Technology Institute. Then Professor Donald Katz is now at the University of Northwest. He's now in Northwest University, but by the time we're collaborating with him, he was in the UK. And also have a collaboration with the University of Rwanda, where we have Phineas, who is from the University of Rwanda. You can see here we have a broad collaboration which has made us to progress at a very good speed, which I think by now is still good, although we still have more to do. Of course, the collaboration also continues with the gender activities. Now you can see here, these are undergraduate female students. And we have here Professor Miriana, who has been very instrumental. And of course, you know, that she's also a gender activist trying to promote female in sciences. And I think because of her outstanding performance, there's an award which was given to recognize her input in development of astronomy. Now, what achievements have we done so far? This is at the beginning. Of course, now our students, they do, to show that they do quality work, the publications. You can see these are in good journals, Manras, A&A, UpJ. Now, so far, we have graduated 3 PhDs. Now, these students, we started training them from masters. Now we have 1 girl and 2 boys. Now for MSc, so far, 21 have graduated.
Sorry to interrupt. You have 3 minutes more.
5 girls, 7 boys. Then, of course, these ones are from Uganda. So also have foreign students from Rwanda, 7, 2 girls, 5 boys. From Ethiopia, we have 2 students, 1 girl and 1 boy. Now we have ongoing students who are still doing their studies. For masters, for PhD, we have 5, 3 Ugandans, 1 girl, 2 boys, 2 from Rwanda, 1 girl, 1 boy. We have ongoing MSc students, 5 from Uganda, 1 from Rwanda, 3 boys, 2 girls. From Rwanda, we have a boy. And I think the challenge with the current number for Rwanda is because of the COVID pandemic. Now, some of the students that we trained at master's level got opportunities to do their PhD outside. There's one who is currently in Italy. Then there's one who finished from Porto University. Now that is just to show that the students that we train can compete favorably internationally. And also some of our students have made presentations in international conferences, and some of them are as invited and others contributed talks as well as poster presentations. Now we have also made some achievements with the library, with the help of American Astrophysical Society. And of course, this is a section of the computer lab that we have developed. Now, what's the impact of the program so far? Now, there's increase in human resource, which we have realized, and seeing the need for astronomy. Now, astronomy has also been introduced in the lower secondary curriculum. And the good thing is our undergraduate students, some of them are trained to become teachers, and we train them also in astronomy. And that makes it easier for them when they go to the field to be able to teach astronomy at the lower secondary level. And of course, seeing the need, there's also been development of the National Space Program, which is ongoing, which we believe that if the politicians don't come in March, we should be able to finalize that very soon. Of course, you know, in Africa, in some cases, politicians can come and really take things in a negative way. And now, with the few that we have already, the few human resources that we have started developing, now there are already other universities who are introducing astrophysics and space science, which really is good because now the market will be there. Because so far, all we have trained are not yet enough. And I think if we continue training more, the market will be there. And it means that we need to do much to develop capacity. Now, as much as we're in the infant stage, I think the most important is for us to start. You see, like what happened when Moses was called to deliver the Israelites from Egypt, God asked him, what did you have? By then he had a rod. So he said, a rod. And I think if he said he had nothing, most likely he wouldn't have delivered the Israelites. So what am I saying? What did you have? Start with what you have. It may be an idea. You can start with that. Then I want to acknowledge the National Astrophysics and Space Science Program because this has played a very big role in Africa. And I think my motivation to join NASP was to go and start astrophysics and space science in Uganda. And I'm happy that I've lived to that dream. Then I also want to thank the International Science Program. I think they have played a crucial role in funding our programs. But of course, the university has provided us with the environment and also some material help. And of course, AfAS is playing a big role, and we're really very grateful that such a platform has been provided for us where we can share experiences. And I'm very sure that with this sharing, we'll be able to get more collaborations. Thank you very much.
Thanks a lot, Edward Jirua. Thanks a lot. We'll just move on to the next speaker, Tolu Biresa. Is Tolu Biresa there at SAO? So I don't see them online. Are they there at SAO in person?
Please, my specialization is on those laptops.
Tolu Biresa,
Yes.
Are they at SAO right now?
Yes, 1 minute, he's with us.
Okay, thank you. Okay. Thanks a lot. Yeah. So the next speaker is Tolu Biresa from Jimma University, Ethiopia, who's going to tell us how to frame a platform of collaboration for both research and education across Africa. So again, I'll tell you when there are 3 minutes up so that you can conclude.
Yeah, I need to shoot. Okay, thank you for the invitation. As you see, my talk is on platform of collaboration for research and education across Africa. It is to steer Africans what to do in the future for the progress of the science, not only astronomy and astrophysics. The content is, of course, introduction, science development agenda, and life zone. And let me go. The motivation. Actually, the motivation comes from my observation, from my teaching experience. I used to teach from grade 7 to 9 since my undergraduate, and at the same time from 9 to 12 I was teaching physics, and then at college, universities, I was teaching. That gives me a lot, and also from my learning experience, research experience, curriculum development. Of course, I have developed several curriculum for the Ethiopian educational system, including a Bachelor of Science in Physics, Bachelor of Education in Physics again, and also for the Ethiopian Space Science and Technology Institute, Astronomy and Astrophysics part, which I have also participated, of course, if not more. Then development program and education setup roadmap in African context, media propaganda itself. Also, I have extracted these things, trainings, conferences, etc., and the outputs are my motivation. So what is science? Why I've chosen science development agenda in the life. Of course, let's go to the propaganda and then come back. Science is a systematic knowledge based on factors and a human experience that links abstract thinking with technology for all development of a community. Without science, we cannot have knowledge. Without knowledge and of course science, we don't have technology. Without technology, there is no development, no infrastructure development, and no civilization. So it helps us to understand all these things that you see, to understand more about our universe, to advance technology, organize our daily activities, to communicate more easily with others, and know better and understand other cultures and society itself, even to communicate with the world. Without that, we cannot communicate. We cannot behave properly. Even we cannot respect each other without broad sense of science. Generally, development program is, of course, a global. I skipped this one already. I have said indirectly. So, reasonable questions for collaboration. Let me present in the form of questions. Why do we collaborate? What to collaborate? How to collaborate? Have the questions communicated to the real agendas of the nations, the region, international, national? That is our main problems in terms of the politicians and, of course, decision makers. Mostly in the African context, they say innovation, so on, so on, so on, but they are unable to deliver to the real nation's agenda. That is a problem we have. So is it implemented? So based on this, considerable platforms of the research and education collaboration across Africa. One, it is important to assess and evaluate the overall education and the research status of Africa without the assessment of where, what is developed, what we have, where, for example, in Egypt, say, or in Ethiopia, or in Uganda, or in South Africa, what do we have? And what do we need in other areas? What do we need from them in terms of human capacity, so on, so on. So this is very important to assess and evaluate. Then sorting out and the detailing of the issues which have been addressed for the assessment. Then design a system of the collaboration based on the assessments and the sortings and the networkings. Develop the principles of collaboration. Without the principles, we cannot do the collaborations and also effectively act on. And involvement of decision makers is very important. Actually, this was also raised by Leratodi, group, and also in some cases by Carolina, but still I am just emphasizing on that. Prioritization of the development areas is very important. Assign task force to develop the system of collaboration. Otherwise, some country or some people do somewhere and the others do somewhere. There is, of course, capacity a building issue, well not communicated in terms of the regional collaboration. Then think of owning some programs, centers, etc., together for effective use of resources. For example, if you take the observatory issues, site testing, and so on, Kenya is trying, Ethiopia is over there trying, and also you have Burkina Faso down. But everywhere there is some trials, but there is no well-coordinated and capacitated issue. That is a big problem. So for human capital and international collaboration, this is very important. Take, for example, Europe, almost they do together. The same thing is true also in terms of the America. Participation of diaspora is very important. The diasporas should participate, but in a way that they benefit their country. Exploit and collaborate internationally with the whole globe. Identification of priority and the phase of collaboration is very important. Design strategic plan for intervention. And understanding variety, culture, language, issue, and other relevant points should be considered. Again, it is the same as what Carolina presented in the morning. Without this one, we cannot also do the collaboration. Accreditation of international standards shall be considered also. We are not isolated from the globe. We are within the globe. And of course, we have to do for our workers, for ourselves, and also globally. Integration and the differentiation of local and international experts shall be taken into account. Mobility shall be considered both locally and internationally. With this regard, there must be a means to establish the sense of go out to learn globally and come back to serve the continent nationally and internationally. This is one of the big problems that we have in terms of the diaspora perspective. Professional rights and responsibilities. I want to also underline on this one. It shall be reflected throughout the platform framework. Without this, we cannot go, okay? We go nowhere because the involvement of the politicians without profession is the disaster part in the African context, whether we like or not. It is this part that is distracting Africa, nothing. So consider the national and international principles of ACTIS. For example, the society should take this into consideration, not only for the AfAS. AfAS shall take into the general, to the science. And we have to effectively act on that. Without that, we cannot communicate with each other. For example, if you take in my society, Ethiopian Space Science Society, of course, I was the first manager of the society. Actually, and of course, for the Lalibela site testing in Ethiopia, which is for the big one, I have, of course, worked out the scientific background. But in some sense, the politicians' involvement is, even though it is good, in some sense it is bad. So this must be taken into account with this, and thanking the AfAS for this professional work, and also for all things that the organizers and others have done. I thank them, and then thank you all.
Thank you so much. Thank you so much, Tolu Biresa. And also thank you for finishing ahead of time. Since you did, maybe you can have one question for you before we move on to the last speaker. Just one question for Tolu Biresa, please.
Yes.
Okay, go ahead then, dear. And this one question, yes, he's coming at this.
I will just take one question.
Of course, for the others. He is using for the others.
Okay, can I talk from it? Can you hear me?
Use it.
Okay, all right. Nice presentation. While you're presenting, you made mention of something that we probably need to look at, and that's probably Africans going out of nations to get trained, you know, and coming back. It looks like we need to probably invest more in that area. So what proposition are you making to, you know, I mean, in your own opinion or wisdom, how do you think AfAS can come into helping such kind of purposes to be accomplished, such that we have more astronomers that are trained and indigenous astronomers from Africa being trained, and then they begin to give back to the nation?
Yeah, and that is okay. And of course, we are working on that right now. It is good. But still, we do have diaspora who are not participating because of their own reasons and because of their national affairs. So I am just proposing when the, for example, the diaspora are going out, not only looking for their advantage, also they have to look inside. But to have this one, we have to have a platform for them from the decision makers. If the decision makers in some part involve, still it is difficult. For example, in the Ethiopian context, almost very nice astrophysicists, professors in physics, in mathematics, all they are not coming and serving. Very few of them are serving, but we have more than thousands of professors, but they are not coming back and then serving. Because of what? For example, we don't have a nationality double standard. okay? Just single nationality. That is one of the factors. So we have to avoid such kind of factors in a way that all nations and nationalities be benefited.
Thank you. Thanks a lot. Thanks a lot for the answer. Let's move on to the last talk. That is from Linda Struber, who's from the Pan-African School for Emerging Astronomers, PASEA. You already heard Bonaventure Okere talk about it a bit the last session, as well as from the Struber Educational Consulting from the US, UK, and Belgium. So Linda Struber, please go ahead.
Thank you.
Okay.
Can you see my screen and can you hear me?
Yes, yes, we can. Please go.
Great, thank you so much. Hi, everybody. My name is Linda Struber, and I'm going to talk today about teaching your best in your university astronomy classroom and online using principles from education research. Thank you so much to the organizers of AfAS, to all of you for being here, to all the speakers so far in this session. It's been a really difficult last couple of years for the world, for me personally, probably for you personally too. And so I'm really extra grateful that we have the opportunity to talk together about astronomy and about how we teach astronomy. This talk is going to focus on university level astronomy, but I think anybody who teaches at any level will find some connection, and maybe students will find some ideas here as well. And I would like to acknowledge that much of my work takes place on the unceded traditional territory of the Musqueam, Squamish, and Tsleil-Waututh First Nations in what we call Vancouver, Canada. That's where I am right now. It's 7:30 in the morning over here, so I'm across the world from you. My connection to AfAS is that I'm the co-director of PASEA, the Pan-African School for Emerging Astronomers, which we heard about from Dr. Bonaventure Okere in the last session. I'm also a freelance astronomy and physics educator and professional development specialist. And my career path's been a little bit unusual, so I'll just mention quickly. My background is theoretical astrophysics. My Ph.D. and my first postdoc were both in theoretical astrophysics, studying the tidal disruption of stars by massive black holes. Along the way, I became really interested in education, and in 2015, I transitioned my career to astronomy and physics education and professional development. So I've worked at the University of British Columbia, the American Association of Physics Teachers, and most recently I've been doing sort of freelance projects with UBC, with AAPT, with the University of Central Asia, and the American Physical Society, and hope to keep broadening that. I focus on university level, especially undergraduates, because it's a crucial period in our educational paths. It's a kind of a bridge between secondary school, which is more kind of outreach, and postgraduate studies. It's the time when students really decide if they're going to become a scientist and or a teacher of science, if they're going to pursue postgraduate studies. And it's the time when students are laying the foundation of scientific content and scientific practices that's going to inform all of their future science career. So in my work, I support university instructors to collaboratively strengthen our skills for teaching astronomy and science effectively and inclusively. And just one note on wording, I'm using the word instructor to mean any university educator. I think in different contexts, we use different words, so I'm using the word instructor. I want to start by grounding our discussion of education in just thinking about our own teaching. So I have a few reflection questions you can think about for yourself. First is, what are you grateful for in your astronomy teaching? Second is, how were you taught science in university? And the third is, how would you and your department like to grow your teaching skills even further? And if you'd like, feel free to share your thoughts on our Slack channel. First, join the Education Outreach and Development Slack channel, and it would be cool to have a conversation about these. I want to focus first on this question of how were you taught science in university? I was taught science mostly by lecture. So somebody would stand in the front of the room and just talk to a whole big room of us for an hour, and we'd take notes and maybe have a chance for a question or two, maybe not. And probably many of us here teach science in that way through lectures and university. It's often what our universities and even our students expect of us. It's how we were taught, and it's a little bit easier. But I think we probably also all have the experience of doing something a little bit more interactive in our teaching and finding that when we give students the space to talk to each other, talk to us, they kind of become more alive and engaged, and it feels like they're learning more. And I want to share with you that there's a really important paper in 2014 by Freeman et al. that backs up that idea with education research, showing that active learning techniques, so interactive ways of teaching, significantly improve student learning. And that could be things like group problem solving, working on worksheets, doing discussion questions, making posters from discussions like we do in PASEA, really anything that engages students in the process of learning as opposed to passively listening to an expert. In this paper, what they did was combine 200 studies in the US comparing active learning with traditional lecture, and found that students in active learning classes were 1.5 times less likely to fail and the class and achieved half a standard deviation better scores on tests that measured their conceptual understanding. So this study with thousands of students, they are all in the US, but this study of thousands of students really gives strong evidence to the idea that teaching in interactive ways can really help our students to learn the most. I also want to bring in a framework of ideas for supporting equity and inclusion in our teaching. And when I say that, what I mean is the idea that we don't just want to teach some of our students, some subset of our students, but we want to support all of our students learning. And that includes acknowledging that many of our students have experienced discrimination on the basis of their gender, of race, of ethnicity, language, religion, disability status. When we think about teaching equity and equitably and inclusively, that's finding ways to ensure that all of our students have the opportunity to thrive in our classes. Some ideas that I'll share here come from the Institute for Scientists and Engineer Educators, or IC. The first big idea is to connect our teaching to our students' goals, interests, and values. And when we're teaching astronomy, that's a really great place to be because so many of our students are already really interested in astronomy, and we just need to build from there towards their goals. We want to support positive expectations for our students' achievement. So have big expectations for what our students are able to achieve, convey to them that we believe in them, and support them to get there. And third, we want to support our students to develop an identity as a person in astronomy or science, to view themselves as a budding member of the astronomical or scientific community through teaching them astronomy and scientific practices and bringing them into the culture of astronomy and science while letting them also maintain all the other identities that they hold as a person. And I'm going to share links to more information about all these ideas in Slack after the talk. Another framework that I don't have time to tell you much about, but it's a great book called How Learning Works, which has 7 principles of teaching and learning that are really helpful. And I'm going to share that with you afterwards too. Now, many of us during the pandemic have had the experience of teaching online. I taught physics for the University of Central Asia in fall 2020. And it's definitely different than teaching in person, and it can be pretty hard. My students came from poor rural mountain areas in Tajikistan, Afghanistan, and Pakistan, and they had a lot of challenges with bandwidth, internet, computers, and I imagine that many of us in this group, if we've been teaching online, have had similar experiences. But I think there are interesting opportunities from teaching online as well. And I, with a colleague, put together a bunch of ideas for online teaching at the beginning of the pandemic in 2 short articles, and I'll share those with you, maybe for some interesting help. So far, I hope you're getting the idea that there's a wealth and growing body of research on teaching and learning that can help us all to teach even more effectively and inclusively. So you might say, great, how can we get support for incorporating these ideas into our teaching? One way is through readings and resources. I'll post them in Slack. If you have some favorites, please share them there too. Next is through teaching skills workshops. I've led many of these in West Africa at PASEA, in Central Asia, in Canada, and the US, and we can collaborate on workshops for your setting if you're interested in that. And the third, which I think can be the most powerful, is creating communities of teaching, which can help us all to strengthen our teaching skills and try out innovative ways of teaching. So I'll spend a little more time about communities of teaching. Often when we teach, we're kind of isolated. There's us and our students, but very often we don't talk with our colleagues in any depth about our teaching. It's kind of us and our students and them and their students. But there's so much that we can learn by just talking to each other. And so communities of teaching provide different ways of doing that. And I'm going to share with you 3 different models for communities of teaching that I've been working on. The first, which is kind of an easy introduction, low commitment, is educator online learning communities. In this, instructors meet bi-weekly on Zoom, which means you don't have to be in the same place. We could get educators from across Africa or even across the world to do this. And you just reflect on your teaching, exchange ideas, ask for advice, celebrate successes in your teaching. And it can be helpful to have an outside facilitator to keep the discussion going, but you don't need it. And I've been doing this in an online learning community focused on equity as part of the APS IDEA program. A slightly higher level of commitment with a bit of deeper learning is teaching triangles. And I created a program like this and conducted research on it for the University of Central Asia. In teaching triangles, a group of 3 instructors get together and observe each other's classes at least a couple of times during the term, then meet regularly to reflect on teaching, and you can exchange feedback if requested. And the most involved is paired teaching. So that's the highest commitment, deepest learning. In paired teaching, 2 people co-teach an entire course together. We often pair a newer instructor with somebody more experienced, and you get to kind of make a deep dive into the pedagogy. You're planning activities together, observing each other teaching, and exchanging teaching feedback. And I created paired teaching for PASEA, and have also, I've been a paired teacher at the University of British Columbia, and we have done research on it. And I want to share just a quick thing about the research that I've done with teaching triangles and paired teaching. Instructors find communities of teaching to be really valuable. So I've conducted research interviews with dozens of instructors, and here's what a couple of them say. Somebody who's a teaching triangles participant said, "Feedback was very, very important, but mostly I learned from reflection while observing colleagues teach. I was mostly thinking about what is it that they're doing? How would I do that?" And somebody who is in paired teaching said, "It's sort of a teaching knowledge and technique transfer that would probably take years to develop on your own, which, to be honest, as new staff or instructor, you don't have time for." And they added, "There's so much we can learn from each other." And we've published some of this research about these research interviews showing how valuable it is. So
sorry to interrupt, you have 2 minutes more.
Okay, thanks. So why do communities of teaching work? They build from teaching experience and wisdom that the group already has. So there you can learn lots of outside ideas, that's great, but there's already so much experience and wisdom that we have together and can share with each other. It gives the opportunity to discuss with colleagues who know your teaching context, and it honors each person's own teaching agency. So there's nobody telling you how you're supposed to teach. You decide on your own teaching goals. If you want feedback, space to reflect, just how you get support towards your own goals for teaching. So in conclusion, there's a wealth and growing body of research on teaching and learning that can help us teach even more effectively and inclusively. And communities of teaching can help us all to strengthen our teaching skills and try out innovative ways of teaching. I would love to chat with you and learn about your astronomy and science teaching, and let's collaborate to support you and your department towards your goals for effective and inclusive astronomy teaching. Here's my email address and my website. You can contact me on Slack, and I really look forward to connecting with you. Thank you so much.
Thanks a lot, Linda. Thanks a lot. So is there any quick question for her? Any quick questions for Linda?
I think we should just speak.
No. Just speak? No? Just speak? Yeah. Okay.
Sorry, just I wonder how you designed this one, how the motivation come to your mind. That is very interesting.
How the idea for these came to my mind?
Yes, exactly. Really, it is interesting.
Yeah, thank you. I've been part of some of these kinds of projects already in Canada and the US. And I've read research about programs that exist. So these are variations on things that have been done in lots of places. There's something in the US called teaching squares. But basically they're all based on the idea that just as when we teach our students, if we give our students the opportunity to interact with each other, that helps them learn. We can also view ourselves when we teach as students of teaching. So giving each other the opportunity to talk to each other about our teaching can also be really beneficial. That's kind of where it comes from. Thank you for the question.
Yeah, so thanks a lot. I think we'll stop here because we're already kind of a little more than half an hour late. And the other session has already started on the African Planetarium Association, which I know many of you would like to go to. So again, please come on to Slack and ask questions there. Let's have a continued conversation on Slack over the whole week. So let me thank again all the 4 speakers, Zarara and Trivanakoto, Edward Jurua, Tolu Biresa, and Linda Struber for lovely talks on how we can implement better policies on education in astronomy, both in schools and colleges, as well as in PhD programs. So with that, thanks everybody again. Please come on to the Planetarium Association session now if you would like to. And see you all tomorrow.
Thank you.